Good morning and good afternoon, everyone. Welcome to our 2021 mid-season summer and tropical weather outlook. My name is Andrea Berg and I will be your host for today's session. I am joined today by our three long-range meteorologists, Jeff Johnson, Nathan Hamlin, and Stephen Strum. I'm also joined today by Troy Vincent, who is a market analyst for our energy sector. So before we begin, I just want to go over a few housekeeping items. One, we are recording this webinar. So if you missed anything, you want to send this presentation to a colleague, we will be sending out a link to the recording with everybody who registered when this webinar is over, probably in about 2 to 3 days after the session. If you're experiencing any technical difficulties, please use the chat feature on the right-hand side of your screen. And we have reserved time at the end to go over any questions. So at any point during the presentation, please enter any questions you have using the Q&A feature or the chat feature on the right-hand side of your screen. So with that, I am going to turn the presentation over to Jeff Johnson. Jeff?
Well, great. Thank you, Andrea, and welcome everyone to today's presentation reviewing the tropical season so far and what we expect for the balance of the year, as well as a outlook into the fall and preview of the winter season. I'll start out the presentation reviewing the 2021 tropical season to date, then turn it over to Nathan Hamlin, our long-range team lead meteorologist, and he will update the balance of the seasonal forecast in terms of the tropics. And then Steve Strum will take a more detailed look on the summer temperature and precipitation pattern, as well as outlook for the fall season, and then a preview of the winter, and then some detailed analytical information from Troy Vincent, who is a oil and gas specialist with DTN. So all of this we do plan to cover, as well as take time to answer your questions at the end. So please do submit those into the chat function. So beginning now with a recap of how the season has been so far. The season, once again, is promising to be fairly active. We already have had 8 named storms, only 1 hurricane so far, but it did impact the United States. No major hurricanes, fortunately. 4 of those named storms did make a landfall, and we have had over $1.2 billion in damage so far this year, so pretty active. Most of that did come with the 1 hurricane of the season. And we did have another year where the season began early, 7th year in a row, with the storm beginning before the season start on June 1st. So I want to focus now on storms that did impact the United States. The first system was Tropical Storm Claudette. That storm was in existence between June 19 and the 23rd, and it did achieve maximum winds of 45 miles per hour as it moved northward through the Gulf of Mexico. And it actually reached those peak intensities right after the storm moved inland, so it's kind of an unusual situation where the storm did intensify after landfall. $350 million damage estimate so far, and up to 14 fatalities reported in Alabama, and some pretty extreme rainfall with the maximum amount reported near a foot in Diamond Head, Mississippi. And the storm also did produce 7 tornadoes as it moved inland and to the northeast. And you can see on that track that the storm continued to progress off to the Carolinas before completely dissipating. So first system to impact the United States was fairly significant in terms of a tropical storm event. Then we had a weaker system come in a week or 2 later, Tropical Storm Danny. This one formed off the southeast coast and moved westward into South Carolina, making landfall at Pritchard's Island. Max winds of 45 miles per hour as it moved inland. No damage estimates have been received so far, but most likely they were fairly minor. And the heaviest rainfall reported was a little over 5 inches at Perrysburg in South Carolina. So generally a minimal impact event. That was followed in the first week of July, though, by Hurricane Elsa. This was a system that developed in the Caribbean and then moved into the eastern Gulf of Mexico and then intensified as it moved northeastward into Florida. It did achieve maximum winds of 85 miles per hour and made landfall in Taylor County, Florida, with winds at 65 miles per hour, so just a little below hurricane intensity. Damage quite high, estimates at this point up to 875 million. There were 5 fatalities, about 11 inches of rain for the maximum at Port Charlotte in Florida. And then we had quite a few tornadoes, 18 of them counted from Florida northeastward along that storm track up into New York State. And also we had some strong wind gusts along the entire east coast of the US and into southeast Canada. So this was somewhat similar to last year's Hurricane Isaias, which did move up the eastern seaboard and produced quite a bit of damage, even though the system had weakened, moving inland and up the east coast. And then just recently, we've had Tropical Storm Fred that formed on August 11th. It moved inland yesterday. It achieved a maximum wind speed of 65 miles per hour and maintained that speed when it made landfall yesterday at Cape San Blas. Damage, way too early to have any kind of numbers on that. But we did have locally heavy rains of 8 to 10 inches reported northeast of Panama City, and rains of 2 to 6 inches are still possible today and over the next several days, moving up the Appalachians. So that graphic in the lower right does show estimated rainfall over the next 3 days, so extending from Georgia through the Appalachians all the way up into New York State. And even later in the week, we will continue to see significant rains moving up into the state of Maine. Also, we do expect there to be isolated tornadoes in the southern and central Appalachians. The severe weather outlook for today is the lower left graphic showing that slight risk of severe weather over Georgia, northeastward into southwestern Virginia. So especially during the afternoon and evening hours, isolated tornado risk. And then for tomorrow, as the center of the remnants of Fred move up toward Pennsylvania, we will see a slight threat of tornadoes into southeastern New York as well as Virginia and eastern Pennsylvania, again, especially during the afternoon and evening hours. So the system has weakened to a tropical depression at this point, but the impacts will continue with the heavy rainfall and the isolated brief tornado threats for the next several days, and even some possibility for Thursday and even into Friday up across New England. And then this doesn't look like it's going to be a U.S. impact, but we also have Tropical Storm Grace out there that has been moving south of Haiti and around Jamaica and portions of Cuba, affecting those areas with significant rainfall and flash flooding and mudslides. Strongest wind so far, 45 miles per hour. And we will continue to see the threat of heavy rains in those areas today, but I'll have to keep an eye on this over the next several days as it does head westward, probably making a landfall over the eastern portions of the Yucatan Peninsula near the Cancun area. And there is some potential that this could be near hurricane intensity when it does make landfall. It will then weaken a little bit as it moves across the land, but then as it moves westward into the Bay of Campeche, could once again re-intensify and make another landfall in the eastern coast of Mexico by late in the week or early this weekend. below that official forecast map are the uh, different model projections of where this storm could go. So there is pretty good agreement among all of the models that it will move on this westward course through the northern Yucatan Peninsula and then again into eastern Mexico. So again, something to watch here over the next several days. And then we also have Tropical Storm Henri out there right now that just formed yesterday in the western Atlantic. Forecast to move westward over the next couple of days and make a turn to the north and northeast. Again, looking at the model forecasts in the lower right, you can see that general idea for a westward movement and then a turn to the north and northeast. Looks like it's going to remain well to the south and west of Bermuda here over the next 5 days. There is some small possibility this could come a little bit closer to the Nova Scotia coast, moving more toward the weekend. Uh, More likely it's going to turn off to the east, but beyond this forecast period, there is some uncertainty on just how far north that'll go. And also it could pick up a little more intensity later in the week. I think the current estimates are somewhere around 60 miles per hour for peak intensity, but again, later in that period it could intensify a little bit more. So that's kind of a wrap up on what we've had so far, including current conditions. Just a quick review on the climatology of tropical season in the Atlantic. And as you can see on this graphic, the peak number of storms tends to be right around September 10th. So we are still close to a month away from the peak of tropical season of numbers anyway in the Atlantic. And that chart does show hurricanes in the red or orange plot, and then, or excuse me, those are tropical storms, and then the yellow shows hurricanes. So both of them tend to peak right around that September 10th, still remain fairly active well into October. And then as we move into late October, early November, the numbers really drop off. So we still have a good 2.5 months of normally active tropical weather. In terms of long-term trends, the small chart on the left represents Atlantic Ocean average temperatures, and there is a multi-decadal cycle that tends to show up where we have several decades where the water is colder than average, and then that reverses to a warmer period, and then a colder period, and then we've been in the warmer phase now, shown in that circle, from about 1995, and so that has helped to fuel the greater numbers of tropical storms and hurricanes over the last several decades. The plot on the right shows the history of, of hurricanes, tropical storms, and major hurricanes going back to 1950. And on the right half of that, you can see that trend of greater numbers of storms and hurricanes due to the warmer phase of the Atlantic Ocean, but also there's been improved detection from satellites. We are able to see a lot of the weaker, shorter-lived storms that are out in the middle of the ocean that prior to satellites were undetected. So we, again, primarily this is fueled by the warmer waters, but also by better detection capabilities. Now, in terms of landfall trends of hurricanes in the United States, looking back over the past 120 years, you can see there is a lot of year-to-year variability in terms of number of hurricanes and major hurricanes that hit the coast of the U.S. Some quieter periods in there, some more active periods, but the overall trend has been slightly downward over the past century. We did have some really quiet years in there. Notice on the right chart, the major hurricanes. Between 2005 and 2016, there were no major hurricanes, which was quite an extraordinarily uh, fortunate period for the United States not to have any majors hit. But statistically and historically, that was very unusual. And I always like to throw this chart in there because people tend to think of hurricanes and tropical storms being associated with with wind damage, but we also do see some extreme rainfall amounts. These are the highest totals ever reported from a tropical system for each state. And you can see some truly remarkable numbers with over 60 inches reported in Texas, and that was just from Hurricane Harvey a few years ago. Florida, 45 inches, 35 inches in North Carolina. But even when you get into states like Kansas, Missouri, Illinois, 10 to 12 inches of rain. So the remnants of these storms as they move inland can still produce some extreme rainfall and flash flood risks. So just putting things in perspective from a historical viewpoint, the U.S. experienced a period of fewer landfalling hurricanes during the most recent decade compared to the last 150 years. And as I mentioned, we had no major hurricanes that made a landfall between late 2005 and 2017, and that was a record span by quite a bit. And since then, we have had four major hurricanes hit the U.S. Since August of 2017. And you don't really need a major hurricane to have major impacts. If you just have a storm of sufficient intensity move into exactly the wrong place, it can produce quite significant disruptions, storms such as Sandy and Harvey. And if we tend to see these landfalls and intensities catch up with historical distributions, the dollar costs are going to be much greater because in recent decades we have added a lot of population, a lot more buildings, a lot more vulnerable infrastructure, and property is much greater wealth. So costs are going to be higher just because of our growth and that increased exposure. And and a landfall coming into one of these dense population areas with the uh, fragile infrastructure does increase the threat of widespread property damage and hopefully not loss of life with a good warning. And other trends we have seen recently has been some of the storms as they approach the North American coast have been moving a little bit slower rather than moving and continuing onward, and that has led to some more extreme rainfall totals. So flash flooding is certainly something to keep in mind with tropical systems, not only the threat of strong winds and storm surge. So that's a recap of 2021 so far and a little bit of a historical perspective. Now, if you'd like to have some idea of how the rest of the season is going to turn out, I'm going to hand it over to Nate Hamlin, and he will give you some idea of what we expect.
Very much, Jeff, and that was a fantastic recap and great historical information with context that the upcoming forecast should be viewed from. Let's first go into some important seasonal factors. So we're looking for three things mainly when we're looking for tropical development to become enhanced. And first things first, ocean temperatures should be warmer than average. You need to have sufficient heat in the oceans that provide the fuel for these storms to strengthen. Another thing we look at is vertical wind shear, or the change in winds with height is what that means. And if you have winds blowing roughly the same direction in speed from the surface all the way up through, we call that low wind shear. And that is a favorable aspect for storms to strengthen. However, if there's winds blowing at different speeds or different directions, that is what we call increased wind shear, and those tend to make storms less organized. You also want an environment where large-scale rising air motion is present. So when all three of these are together, that's the best environment available for tropical development. And we apply those three factors across the main development region, which is defined from just west of Africa through the Caribbean Sea. And what we like to see is, you see on the right-hand side, a stronger and wetter West African monsoon. What that does is spit out tropical waves that go westward into the main development region. If those waves encounter any of those three, and especially all of those three favorable parameters, a storm is going to strengthen more quickly. However, if those parameters aren't favorable, those waves will come out into the Atlantic and they won't become as strong, or they might even die out. So what we're looking for is stronger and wetter West African monsoon that can spit out more waves into the Atlantic if you want an active hurricane season. So the main seasonal drivers, and most of the main seasonal drivers you look at come in the form of ocean temperatures or sea surface temperature anomalies. And what you see on the right is a map of forecast sea surface temperature anomalies from September through November. Where you see the oranges, that's above normal water temperatures, with the blues below normal water temperatures. So focusing on the area west of South America in the tropical Pacific, you see a bunch of blues in place. So that is what we call La Nina. That's forecast to develop through the fall season during the peak part of the hurricane season. And we focus on the positive AMO. What that typically means is warm water temperatures in the Atlantic Ocean. And another thing we look at is the minus PDO, which basically means a lot of warm water in the central and western North Pacific, and with cooler water right along the US West Coast. So what we like to do is look back in the historical record to find years that exhibit sea surface temperature anomaly patterns very similar to what we expect this year. This can give us some clues on where the pattern might go. Let's focus in on ENSO for a second. And what you see here are different storm numbers per year broken down by ENSO phase. And let's focus a lot on the since 1995, since it's a little bit more relevant than the 1950 part. So all years since 1995, 15 named storms, 7 hurricanes, and 3 major hurricanes there have been on average. If you look at El Nino, though, that drops all the way down to 11, 5, and 2. So usually when you have El Nino, you have less storms in the Atlantic Basin than average. Looking down towards the bottom, though, we have neutral and La Nina here, and you see 16 named storms, 8 hurricanes, and 4 major hurricanes, and 17 hurricanes, 17 named storms, 9 hurricanes, and 4 major hurricanes, respectively. So what this is telling us is that when you have neutral and especially La Nina conditions, you have more storms than you would have on the overall average, and especially more than what you would have during an El Nino year. So our analogs here, we took a look at those years, and we've came up with several. Here's our top 7. And 2000, 2011, 2008, 2007, and our ominous friend 2005, and 1956 and 2017. Our average is 17.4 named systems, 8.3 hurricanes, and 4.1 major hurricanes. And if we compare that to historical averages, the overall 1991 to 2020 historical average, 14 named storms, 7 hurricanes, and 3 major hurricanes. And the ENSO neutral years since 1995, 16 named storms, 8 hurricanes, and 4 major hurricanes. Our average is higher than both of those. So this is the analogs are telling us that it is going to be a busy hurricane season. So let's take a look at the current sea surface temperature anomaly map here. And where you see those blues in the tropical Pacific, you can see our developing La Nina, and it has trended cooler in recent weeks in that area, and that should spread out further into the tropical Pacific over the upcoming weeks. Otherwise, there's a ominous shade of orange from the Atlantic, across most of the Atlantic Basin, the Caribbean, and especially the Gulf of Mexico, where a lot of warm water is waiting, and that's very ominous for an active season. One thing we're going to have to watch for the next couple of weeks, though, is the onset of Saharan dust. And what that means is some of these tropical waves will pick up some dust over the Sahara and eject them westward over the tropical Atlantic Ocean. When that happens, sometimes you get the storm numbers to decrease, and the waves that you get are weaker, so it puts out a lot of dry air, and this really inhibits tropical development. So we're going to have to wait for this to work itself out here before we see even more tropical storm enhancement. Let's take a look at the CFS model forecast of some tropical parameters, and on the left you see sea surface temperature anomalies from September through November, and there's a lot of orange there, which is indicative of above normal sea surface temperatures. And you can see, especially from the Gulf and just off the southeast coast, so Usually what that means is you have to watch out for storms that are able to strengthen as we get a little bit closer to that region. And there's even if it's just near normal, like some of the white colors are, that's still sufficient heat to produce more active storms. However, looking on the right, this is the wind shear that we spoke of earlier, and we have orange colors. That means there's more wind shear than normal. The blue colors would indicate less wind shear than normal. Remembering that more wind shear than normal would indicate a less than favorable aspect here. And so from the main development region, especially as you get east of the Lesser Antilles, a pretty strong signal for above normal wind shear. There's a little bit of a lesser signal near the Caribbean islands and getting towards the Bahamas, but there's a little bit more shear as we get towards the Gulf of Mexico and the southeast coast. So temperatures would indicate would be more favorable for a more active season, but the wind shear is not quite as favorable. This is probably what's going to separate this year from the very, very hyperactive 2020. Let's take a look at the rainfall forecast from the ECMWF model from September through November. And what you're seeing here is a reduced rainfall signal across portions of the Gulf of Mexico and portions of the Southern Atlantic into the Caribbean Ocean. So the European model is a little bit less keen on very active storm conditions across those areas. So now we talked about factors that talked about the number of storms that are going to occur. Let's talk about where they might go. And upper air patterns can give us a sense of the steering flow. It can give us some clues on where landfalls may or may not take place here for the rest of the tropical season. And Jeff spoke of that lower landfall period from 2006 into 2017. So we took a look at the 500 millibar height anomalies, and this can, again, gives you a little bit of a sense of what the steering flow was like. And you saw a trough of low pressure right along the eastern seaboard here, and with a lot of high pressure to the north of that. So you can imagine some storms that were able to come westward through the Atlantic. They would encounter that trough, they would be lifted up to the north and eventually kicked up to the northeast. There's a lot of that where we had those storms that were actually there, but they actually recurved and pushed away. So they kind of acted like a barrier to a certain extent. And their high pressure system wasn't far enough southward to keep the storms pinned far enough south to give us frequent landfalls. Now let's compare that to the hyperactive 2020. And you see something that's a little bit opposite. So the trough is a lot weaker and is pressed further west towards the Mississippi Valley. The ridge of high pressure is much further south, right off the eastern seaboard, and extends even into the southeastern part of the United States. So you can imagine a storm coming westward through the Atlantic. It's unable to recurve to the north because the high pressure system aloft is blocking it in the way, or it's blocking its northward progress. So it is going to be forced to keep going. Eventually, it will encounter the trough in the Mississippi Valley, be lifted northward, but that brought a lot of storms northward into the Gulf of Mexico. So that explains a lot of the frequent landfalls that we had there last year. So let's compare that to the 2020 analog average to see if there are any similarities to either scenario. July through October here, and well, first thing that stands out is the low pressure system right along the eastern seaboard. So that has been happening to a certain extent so far this season, and the analog suggests it will continue to happen through the peak part of the tropical season. But one thing that is also occurring is the high pressure system is not nearly as far south, and everything is a little bit further north across central and eastern Canada to the Canadian Maritimes. So you can imagine a storm coming westward through the Atlantic and into the Caribbean. Well, the low pressure system is going to be able to pick it up, and there's going to be no high pressure system to block it. However, the high pressure system being where it is, it's not going to allow it to recurve out to sea as easily either. So what we'll be looking at here is a higher risk of landfalls across the east coast. Western Gulf of Mexico could be a little bit more protected overall, even though it's not going to be a universal signal, but that will keep many of the storms from being able to continue westward through the Gulf of Mexico. Obviously, storms like Grace can sneak through, but it will not be the mean pattern, and we'll see more storms being pressed further north and to the east of that region. So let's wrap that all up into the 2021 DTN tropical outlook. We're going to go with 22 named storms, a solid above normal year, 9 hurricanes and 4 major hurricanes. It will be a lot less than the record year that we had last year of 30 named storms. And part of that will be because we had a quiet period already through July into very early August. And other part of that is the increased shear will act to limit the number of storms compared to what we had last year. But even so, this is a strong signal for an active year. Our elevated potential, the best chances for landfall will be across the eastern Gulf of Mexico, the southeast coast, and another area of somewhat elevated potential across the northeast. Now, the northeast doesn't get that many storms, so elevated potential doesn't guarantee that one is going to get up in there. However, this will be one of those years we're going to have to watch more than others. A review of our Atlantic storm names and already through Henri. So we've taken a good bite out of this list already, and hopefully we won't need the supplemental list past Wanda, but the forecast will suggest that we'll get right on the bitter edge of that. So the key messages. Conditions remain favorable for another active season in the Atlantic, although not quite as active as 2020. Model guidance shows warmer than normal water temperatures. Wind shear forecasts have trended higher, which will help limit the storm activity and the intensity to some degree. Analog upper air patterns show that Atlantic storms will be more favored to impact the northeast U.S. and the Florida region with reduced risk to the western Gulf of Mexico. Late season storms will be possible as the La Nina is not only expected to persist but intensify through the fall season. And maybe the more important factor here, even a weaker tropical system can have significant impacts if it strikes a more vulnerable location or moves more slowly. I'm going to pass this over to Stephen Strum to talk more about the late summer and fall forecast. Take it away, Steve.
Thank you, Nate, for running us through the balance of the hurricane season forecast. And now we'll go ahead and take a look at the forecast in terms of temperatures and rainfall for the upcoming fall season, and as well as a little bit of a preview for the upcoming winter. So looking forward here, or before we start looking forward, let's do a little bit of a recap on where we have been so far this summer season. And the temperature and precipitation maps you see are what we're expecting the final June to August composite to be. And so most of the country has had a hotter than normal summer, particularly across the western and really the northwestern U.S. especially. And we have had, though, some pockets of a little bit slightly cooler than normal weather across Texas and the south central U.S. in general at times this summer. And so the overall pattern is really featured the strongest heat in the lowest population portions of the country. So a lot of the Rockies have been extremely hot, as well as northern plains areas, but those are very low population areas relative to the East Coast and the Southeast. And so on a population weighted basis, while we have had some extreme and record heat this summer in many areas, it's only going to come in 9th or 10th hottest in the past 40 years, just based on the distribution of where the strongest heat has been. Now, rainfall has been very heavy across much of the southern and eastern U.S., and that rainfall across Texas is really what has been helping to keep temperatures there suppressed and preventing those typical widespread long runs of 100-degree days that you typically see down there. And similarly across the eastern U.S., the rainfall we have seen has helped at least limit the warm anomalies in those areas and prevented them from being as intense as they have been farther to the northwest. Now, looking at the outlook for the next several months, the overall warm pattern should continue. There will be a lot of variation in week to week, especially as we head into the fall season, and we do see the overall variability levels increase just with the progression of the seasons. But overall, September should still average warmer than normal for most of the country. But one item of note is that we are looking to see the sort of focus for the warmest anomalies kind of shift out of the northwest, the northern Rockies, and into the middle portion of the country. So we could actually see the West Coast trend more seasonal as we head into the month of September. So certainly a nice break for those areas and perhaps a little bit of a help in terms of their fire season out there. But the overall warm pattern should continue for most areas into October. November is a little trickier. We are looking at the potential for an increased risk for a period or two where we see some colder weather across the central and eastern U.S. And so Of the 3 months, November has the best chance to see temperatures come in below normal across a large area of the country if it's going to happen. And so while we are still forecasting the western and northern US to come in warmer than average during November, that month has the highest risk to end up a lot colder than what we're currently forecasting. Now, looking at the rainfall forecast, the key item of note here is that we are looking to see a large portion of the southeastern quadrant of the country stay drier than normal this upcoming fall season. However, the caveat there is that is going to be in all the areas that do not see a landfalling tropical system. So any areas that do see a landfalling tropical storm or hurricane, especially a large one that has a lot of moisture with it, will more than likely average wetter than normal for the fall season. But outside of the tropical influences, the pattern should be drier than normal. So if you don't get a hurricane or tropical storm, you're probably going to be drier than average across the southeast this fall. If you do get one, then you're going to see a lot of rainfall condensed down to a day or two that will skew the entire seasonal average potentially to wetter than normal. But otherwise, we are looking to see the focus for rainfall in September from the non-tropical influences be across the southwest up through the northern plains. So those rainfalls in the northern plains area could help to ease the drought a little bit in those areas that has been building all summer long. But we should see the pattern potentially revert back to a drier regime by October. As we look at the drought situation, we are, again, obviously in a very severe drought across a large portion of the western and portions of the north central US. And little change to that is likely through October. Again, we could see a little bit of an easing across the north central US with the potential for more rainfall coming up here in September. But there are some pretty large rainfall deficits, and so we will likely erase all of those. But as we progress into the winter season, or at least later fall, we are going to see the jet stream drop farther south. Storm systems will increase in frequency across the northern tier of the US later in October into November. And so that should hopefully provide some easing of the drought in those areas, at least from the levels that we currently have. But the southwestern half of the country, they're likely staying with the drought right on through the fall season with little overall change. Now, looking how that will impact the fire season, obviously, that drought will translate to an increased fire risk to most of the western and the north central US during September. And again, as the seasonal patterns shift and we see an increase in storm systems across the northern US during October and November, that should gradually decrease the fire risk for those areas. And then California will likely continue to have an elevated fire risk right on through the fall season until those winter rains arrive, whenever that happens, later in November or in December. Also, with the southeastern US, that's again a little bit trickier. If we don't see a landfalling tropical system, the overall pattern will be drier than normal, increasing the risk for drought expansion and fire risk as we head into the latter part of the fall season. If we do see a tropical system, though, in September or October, that will of course bring a lot of rainfall, and then that fire risk will be dramatically lower. Now, a little bit of a preview here of the winter outlook. This will obviously change quite a bit going forward, and we are going to have a winter outlook webinar on October 20th that you can look forward to, and this will likely change between now and then. But early indicators do suggest that we do have an increased risk for colder weather this year relative to the last two winters. Last year, we obviously had an extremely cold middle of February, but the remainder of the winter from November through March was otherwise very warm. And so this winter will likely end up colder than the last two winters, and it could end up even colder than currently forecast. The combination of a weak La Nina, we also have a negative QBO regime, and some other factors are very favorable for an increased risk for cold this winter season. There are still some factors that favor warmth, however, and so we'll have to kind of see how those evolve here during the next month or two as we head into October and when we have a better idea of how things will be in place for this upcoming winter season. But certainly, the overall trend looks to be for the north central US having the best chance to average below normal this winter season. The southern tier of the country, the most likely area to average warmer than normal as it stands now. And again, though, there is an increased risk for cold relative to some of the recent winters. Again, these maps are still based on the 1981 to 2010 climatology. We are going to be updating our climatology to 1991 to 2020. Starting in mid-September. And so these forecast maps will actually just look a little bit cooler once we do that, because the last 10 years has been very warm on average relative to the previous 30. And so these maps will trend cooler looking by the time we get to our October webinar, just because of the shifting normals that we'll be using in our climatology. But regardless of that, though, there is the risk that we could see an actual shift colder in the forecast during the upcoming couple of months, depending on how things evolve. But the bottom line, though, is certainly northern tier of the country does have an increased risk for cold relative to the last 2 winters as it stands right now. So kind of summarizing here the fall outlook before we progress on here with the webinar. Again, across the western half of the country, the main focus will be the dry weather, the heightened fire risk that really will not abate until we see the pattern shift into a more winter-like regime with increased storm systems and rainfall later in the fall season. Across the eastern U.S., most areas averaging milder than average through October. And then again, some increased risk for colder weather developing during the month of November. The East Coast does have that increased risk for tropical activity, especially across the Southeast and up across New England. And again, those areas that are impacted by a tropical system will likely average wetter than normal, but everywhere else that does not see a tropical storm impact should stay drier than average for the upcoming fall season. And so with that, we'll pass things on to Troy, who can take us through the potential impacts of this on the oil and gas markets.
Thank you very much, Stephen, and everyone at the meteorology team. Let me go ahead and get started here. All right, so as Stephen and everyone said, my name is Troy Vincent. I'm an oil and gas analyst here at DTN, and today I'm going to be outlining what the meteorology team's hurricane season forecast means for oil and gas markets. Let's just get started with the basic risk to oil and gas market supply and demand balance components during the hurricane season. First off, we have the risk of shut-in offshore oil and natural gas production, the risk to shut in refining capacity on the Gulf Coast and Atlantic Coast, delays in exports of crude oil, refined products, and LNG, delays in imports, particularly crude oil on the Gulf Coast and refined fuels on the Atlantic Coast. But ultimately, the storm's track and the directional bias of storms for the season is key to assessing the risk to energy infrastructure. After all, the Gulf of Mexico accounts for a little over 15% of crude production and nearly half of total refining capacity in the country, as well as half of the natural gas processing plant capacity in the country. Reflecting a bit on what happened in the record-setting 2020 hurricane season, we can see from these headlines that even during the same hurricane season, storms can have a very different impact from week to week on oil inventories, depending on the relative impact on all of the variables I just described in the previous slide. You know, some weeks you're going to have a disproportionate impact on, for example, offshore production. Other weeks, depending on the storm, not just its trajectory, but as the meteorology team discussed, the wind shear, kind of how long the storm hangs offshore or just, just at the shore, can make a massive impact on one of these variables relative to the other. So, for example, last year we saw periods where you would have extreme amounts of flooding, but not too bad of conditions at sea, which would essentially mean a disproportionate impact to refinery runs. Refinery runs would shut down, but production would keep up, and that would lead to a large build in oil inventories. And then, vice versa, when you would have offshore production shut in, but not much refining capacity shut in which case you would get a very large draw. Let's start with production, as we kind of work through these variables. With the record-setting storm season back in 2020 came the largest impact of offshore oil production since Gustav and Ike back in 2008. Offshore oil and gas production is generally one of the first factors that we see impacted by hurricanes as they evacuate offshore platforms well in advance of and shut in production well in advance of the storm making landfall. As you can see here, I note that last year we saw about 41 million barrels of offshore crude oil production shut in. And unlike things like imports or exports, which might be able to, they can play some catch up and, really export a lot more than they in the following weeks of a storm or import a lot more. The offshore production really doesn't work that way, and you're not going to really see that made up for. And as such, last fall, the very active hurricane season that shut in so much production really threw a major bone to the oil price and to the oil markets and those hoping for higher oil prices, as it really did limit inventories throughout the, the later half of the third and the fourth quarters last year. As you can see here, I note, the last year we saw about 41 million barrels of offshore crude oil production shut in. And unlike things like imports or exports, which might be able to, they can play some catch up and, really export a lot more than they in the following weeks of a storm or import a lot more. The offshore production really doesn't work that way, and you're not going to really see that made up for. And as such, last fall, the very active hurricane season that shut in so much production really threw a major bone to the oil markets and those hoping for higher oil prices, as it really did limit inventories throughout the, the later half of the third and the fourth quarters last year. As you can see here, roughly 70% of offshore oil and gas production is west of New Orleans, and nearly all of the Gulf of Mexico federal offshore oil and gas production is west of Pensacola. A storm season with an eastward bias that would largely avoid territory west of New Orleans would certainly be welcomed by oil and gas producers after a year like last year. And all the little gray dots that you see down in the Gulf of Mexico image on the left-hand side are wells that are out in the ocean producing. Tropical Storm Fred is a great example of how a storm holding to the eastern Gulf avoids any major impact on oil markets, as you likely noticed over the past week. The next variable that we should discuss is refining capacity. With the vast majority of U.S. refining capacity located in Texas and Louisiana, a storm season that primarily sees increased activity along the eastern Gulf and Atlantic coast should also limit the impact on refinery runs relative to what was seen in 2020. Even more geographically concentrated than production or refining capacity is U.S. export capacity, as it's heavily weighted to the west of Beaumont area, and that red star there on the map is just pointing out the Beaumont, and you can kind of look down to the left as you pass Houston and work down towards Corpus Christi. In fact, 90% of U.S. crude exports are loaded west of Beaumont and primarily come from Corpus Christi, as you can see in this chart here with data from Clipper Data. Smaller volumes are loaded from Houston and Beaumont, and then even smaller volumes elsewhere. When it comes to refined fuels demand, hurricanes serve up a pretty mixed bag when it comes to demand. In general, they're bearish demand. They limit demand. But as I say here, you also see these kind of periods where you get an initial spike as people kind of try to go out and fill up just in case of an emergency or in case they need to evacuate. But then that's generally followed by a pretty large lull in demand as well. Using our proprietary refined fuels demand, which you see charted here, you can see the lasting impact of a large damaging storm like Hurricane Harvey, but far less noticeable are last year's hurricanes. That, as mentioned earlier in this discussion, Hurricane Harvey had such damaging flooding, and that's another reason that the rainfall amounts are just almost nearly as important as wind speeds when it comes to hurricanes or the storm season, particularly for the oil and gas sector. Now, while most of my attention today will be given to the Gulf Coast region, the elevated potential for Atlantic Coast hurricanes means impacting one of the largest regional sources of refined fuel demand globally. And it's worth noting that the Atlantic Coast gasoline market has changed markedly over the past year in the kind of the post-COVID era. As I say here, and as you can see displayed on the chart on the right-hand side, despite PAD 1 or East Coast fuel demand, gasoline demand being just about 3% below 2019 levels, refinery runs in the same region are about 25% lower than the same seasonal period. So, you're essentially, what this chart is showing you is that the supply for the East Coast, when it comes to gasoline and refined fuels in general, but particularly gasoline, has been increasingly imported, and it's been being met with imports since the initial major downturn amid COVID. However, so there is that risk that there is the risk that the hurricane season working up the Atlantic coast, does cause problems for gasoline supply. However, it's kind of a mixed bag as well, because spare capacity in other regions of the country, like the Gulf Coast, for example, which produces much of the gasoline that the Atlantic coast uses, that's pushed up the Colonial Pipeline. Spare capacity in that region is more than it was, back in 2019 as well. So even if the Atlantic coast refiners have to limit their runs due to storms, if at the same time the Gulf Coast refiners are able to run at full capacity, they have the margin at the moment to be able to kind of make up for that and try to push higher volumes up the line. All right, so to just kind of move on to total refined fuel stocks in the U.S., they're at or just below that pre-COVID trend, as you can see in the charts here. A potential major storm hitting the Louisiana and Houston region, taking out refining capacity for a prolonged period and pulling fuel inventories lower, looks to be the most bullish potential risk for this storm season, given the relative, kind of balance, as well as the inventories of the whether you're looking at crude or refined products. To summarize this storm season impact on oil markets, I think, we can kind of hit these 5 bullet points as the major takeaways. We've got the forecast calling for increased activity along the East Coast and the Eastern Gulf of Mexico, which really makes refined product demand or oil demand at a greater risk than supply this season. Yes, this hurricane season is expected to be highly active, but it's not the same season that we saw last year, as the meteorologist described earlier. And as such, we should expect less shut-in offshore production and less shut-in refining than we saw back in 2020. Yes, we're likely to have some delays in imports and exports, but with that eastward bias to the storms likely, it shouldn't really cause material issues for either refiners or fuel wholesalers or retailers or motorists, really. At the end of the day, we also kind of have to realize that, yes, there's this kind of bias for the season, but with the absolute kind of total storm number, the high number that is expected, there's a likelihood that at least one kind of slips through and veers into the Louisiana, Texas area, impacting and shutting down offshore oil and gas production. And it wouldn't surprise me, and I don't think it should surprise the markets if we get, kind of one, oversized inventory draw on the back of a storm like that. Ultimately, however, when it comes to the storm's impact on oil prices, the storm season's impact on oil prices, I should say, I think that there are going to be other kind of more macro variables that are going to have a larger impact on crude prices for the remainder of 2021. Primarily COVID, what's happening with demand as that develops, the US dollar, etc., what OPEC does, for example. All right, so now we're going to move on to natural gas. While natural gas makes up just a little bit of my slides today, and the natural gas market is at much lower risk of impact due to hurricanes than the oil market, I wanted to highlight what's going on in the oil or in the natural gas markets, because I believe that natural gas prices are going to become a growing area of discussion and concern for pretty well everyone as we move into the winter and as hurricane season draws to a close. As I have listed here on the left-hand side, and you can see displayed in the price chart on the right, we're near, I think we're at about $3.85 currently, but near the $4 per MMBTU at Henry Hub at the U.S. Futures benchmark. And prices are already their highest since the winter of 2018, and seasonally they're the highest kind of non-winter pricing since back in 2014. And that has a lot to do with what's happened in the post-COVID era. But also, all these factors have led inventories to be about 5% below the 5-year average currently. And I'm going to just dive into this in greater detail in the coming slides, but given the kind of low risk that anything in the Western Gulf is going to see this year, we should expect that the exports of LNG remain extremely strong. And with that kind of lower risk to the export terminals relative to 2020, it likely means that we're going to see continued record exports of LNG, and that's going to continue to pressure U.S. inventories. So the chart that you see here is the JKM marker, kind of the arbitrage or the spread between the JKM price of LNG, which is the Japanese Korean marker. It's kind of the East Asian marker for LNG. And as you can see here, the spread between that and the Henry Hub futures benchmark natural gas price here in the United States. So high temperatures in East Asia this summer, coupled with nuclear generation issues in Japan, this really helped push the JKM marker LNG price to its largest non-winter premium to Henry Hub since back in 2012. You can see what happened last winter with this spread as it blew out amid a really short natural gas market in the East Asian area that experienced really cold winter and were really low on natural gas or LNG and natural gas inventories heading into the period. Surging demand for LNG in Asia, Europe, and Latin America has helped pull our U.S. LNG exports to a record high this year. Just as my theme kind of on the oil discussion was the geographic concentration of infrastructure, for the risk posed to natural gas infrastructure, this storm season, I'm also going to focus on exports and the kind of geographic concentration of those export terminals. We have about half of all natural gas processing plants located in the Gulf Coast region, and nearly 90% of all LNG exports, as you can see here, And as I note, about nearly 90% of LNG exports are west of Lake Charles. Last year, during the hurricane season, the Sabine Pass and Cameron LNG terminals shut down operations in anticipation of the approaching storms, much like the refiners and offshore producers did. If exports are shut off amid hurricanes this season, it'll likely lead to larger domestic natural gas storage builds and weigh on U.S. natural gas prices. But in turn, it'll also cause global LNG cargoes to become more scarce and global natural gas prices to push even higher, likely pulling harder on LNG exports once the terminals reopen post-storm. So to kind of summarize my hurricane season outlook for natural gas, I think these are the largest takeaways. Essentially, offshore production is just a small percent of total U.S. natural gas production, around that 2% figure, as I noted earlier. And it's at less risk this storm season than it was last year with that eastward bias to the storms. With the elevated storm risk in eastern Gulf of Mexico, risk to the terminals of the exports, as I just described, and in natural gas processing plants is much lower this year than last year. That means that record or near record LNG exports and pipeline exports to Mexico are expected to and should continue. The natural gas production is not expected to, in the U.S., is not expected to hit pre-COVID levels until the end of next year. And given the forecast that Stephen just laid out for the potential for a colder winter, larger than normal fall builds are really going to be needed. We're really going to need those warmer temperatures that he discussed potentially, in that kind of September, October period. We're going to really need those warmer temperatures in the U.S. to lead to larger than normal fall builds to natural gas storage to help keep Henry Hub winter prices below that $4 per MMBTU level. So that really wraps up what I have. I'm going to turn it back over to you, Andrea.
Fantastic. Thanks so much, Troy. So we have come to the end of our formal presentation. If you have any questions, please feel free to put them in the Q&A feature on the right-hand side of your screen or the chat feature on the right-hand side of your screen. So I will ask our presenters, do you guys see any questions?
A couple have come in here so far. 2005 was a historic year, and I do see it on the analog list. Can you guys detail the main difference between this year and that year and what it might take for this year to become like that year? And I can take that question. 2005, I think the main difference between this year and 2005 or even 2020, for example, would be the amount of shear that is forecast to be in the Atlantic Basin and the main development region. So those years there wasn't much in the way of shear, not much in the way of anything to stop these storms from forming and becoming intense. This year, there's forecast to be a little bit more shear, and what that will do is act to reduce the number of storms, but also reduce the intensity of some of the storms. So we think there's going to be a couple peak periods this year where it's going to look like those years, but this year is going to limit those periods, the duration of them, and it will probably cut down the number of storms. So while this is an active year, we do anticipate that factor would cut down a little bit. Now, if that shear isn't there and all the guidance we're looking at is wrong about that shear, then all of a sudden things could get a little bit dicey and we could see increased numbers of storms. But even so, even at the pace we're at, I don't think we're going to quite make it, especially on the hurricane and major hurricane front. Let's see, are there any other years or any other questions here? Do you see the risk for storms very late in the season, maybe even into December or January? And what do you think, Steve?
Yeah, I can answer that. Yeah, the pattern this year, well, there's a couple of factors that are going to favor the hurricane season lingering longer than sort of the traditional hurricane season. One, we do have most of the Atlantic basin warmer than normal this year. And so that, as long as those water temperatures remain in the upper 70s and 80s, that does provide enough fuel for hurricanes to keep developing longer than you normally sort of expect. And so that will be in place this year. So that will be favoring tropical development right on through November, maybe even into December. Also, as we progress through the year or through the balance of the year, we do expect the La Nina that's developing now in the equatorial Pacific to strengthen and likely peaking in December. And as the La Nina strengthens, over the next several months, that should have an influence on the amount of shear in the tropical Atlantic. So we could actually see, while there's potentially more shear here in the next, maybe a couple of months, you could actually see the wind shear be lower than average by the time we get to November and December. Shear still increases, on an absolute basis as we head into winter, but it could be lower than average during November and December. And combined with the water temperatures remaining warmer than normal, that should produce or promote more storms than typical during November. And maybe we will see another storm linger into December as well this year. So we are likely to see that hurricane season kind of just keep going this year and not really come to an end until probably sometime in December, not unlike what we saw last year. So that will help us get to those higher storm totals as well, just the overall longevity that we'll likely see with this hurricane season.
And I might just add to that typically those real late season storms tend to be further to the south, more in the Caribbean Sea area and off the southeast coast, more toward Cuba and south of Bermuda. So even if there are late season storms, it's less likely that they would impact the United States. More likely those systems will be further down toward the northern Caribbean region, fortunately.
Thanks, guys. Thank you very much. Got one more I think we have time for before we end today, getting past the top of the hour here. So we talked a lot about what might happen with storms that are coming from the tropical Atlantic, but can we talk a little bit more about the potential for close-in development? What factors are for and against it this year? Think you could take that one, Jeff?
Yeah, sure thing. Yeah, conditions will remain favorable right through the fall for close-in development in that area that we highlighted in the northeastern Gulf through Florida and then off the southeast coast. As we move through the fall season, we tend to see storms form along frontal boundaries that drop southward through the United States, and if they do stall out along the southeast coast, sometimes we do see development occur near those boundaries, and I think the pattern is going to remain favorable for those type of scenarios. As we saw in some of the other seasonal forecast graphics, the main development region conditions are not quite as favorable down there. So a lot of those long track systems that do tend to come in during the latter part of the season, those may be less frequent this year, but conditions do remain more ripe for development in that Northeast Gulf region and then off the southeast coast of the U.S.
Thank you very much, Jeff. All right. I think that's all the time we have for questions today. Andrea, you want to close this down for us?
Great. Thank you, everyone. I did get a bunch of questions about getting the presentation. We will be sending out the rebroadcast hopefully by the end of this week, so check your emails for that. And I know we mentioned it earlier, but save the date for our Winter Seasonal Outlook webinar on October 20th. So look in your emails at some time in early October for those invites. So with that, thank you and have a great rest of your day.